All right, so let's take a look at these a little bit. These are the answers that you should have gotten. X is greater than 3 or x is less than -2. And how do we graph that on a number line? Well, since it's an or, it's going to be a split. Here's our 3. Here's our -2. X is greater than 3 would be an open dot. Greater than would be to the right. X is less than or equal to -2 would be a closed dot. Less than or equal to would be off to the left. And so that would be x is greater than 3 or x is less than or equal to -2. Now the second one here, this is an and statement. That means it has to satisfy both conditions. Now make sure here when you divide it by the negative that you flip the inequality sign. So this is x is greater than or equal to -2 and x is less than 4. So we draw our number line. We've got our -2, we've got our +4, 0 is about here. -2 is a greater than or equal to, so it's a closed dot. +4 is a less than, so it's an open dot. And we need everything bigger than -2 and less than 4, so it's got to be in between those two pieces. We're going to come back to that in a few minutes, but that's what you need to know for tomorrow, or for later on today, excuse me. Now, the first thing that we're going to determine is if the following are linear, quadratic, or neither. I don't know if you remember, but back when we were looking at this with the linear equations, if the x's change and the y's change at the same rate, then it was linear. It's a quadratic if the second difference is the same. So let's see what we're talking about here. Let's do this first one together. So let's take a look, and you might want to write this down. So I'll give you just a minute, pause it right here, and you can write this down. If the first difference is the same, if the x changes at a constant rate, the first difference of the y's, okay, quadratic if the second difference for the y's is the same if the x's change at a constant rate. So let's check our x's. How do I get from -4 to -1? I add 3. How do I get from -1 to 2? I add 3. How do I get from 2 to 5? I add 3. So those x's are changing at a constant rate. How do I get from -14 to -5? I add 9. How do I get from -5 to +4? I add 9. How do I get from 4 to 13? I add 9. That's the difference between each of those y's, and it's the first time we've done it, so this is a linear function. Okay. Now let's check these. We know these x's are the same as these over here, so they're going to go up at a constant rate. Let's see what happens. How do I go from 11 to -4? Well, I subtract 15. How do I go from 4 to -1? I add 3. How do I go from -1 to +20? I add 21. Now let's see here. So it's definitely not linear because my first difference is not the same. Let's see about here. Excuse me. How do I go from -15 to +3? I add 18. How do I go from +3 to +21? I add 18. That's the second time I did it. That is a constant for both of those. So this would be a quadratic function. All right, so here's a couple for you to try on your own. We already know the x's go at a constant rate because they're the same as before. So you try these two. Do the first difference and then do the second difference. You might want to pause it here. All right, so let's talk about these. -63 to 0, what do I do? I add 63. 0 to 9, what do I do? I add 9. 9 to 126, what do I do? I believe I add 117. Okay. What is the difference between 63 and 9? I subtract 54. What is the difference between 9 and 117? I add 108. Oops, sorry, 108, not 180. Are those the same? No, they're not. That wasn't the same for the first difference, and it wasn't the same for the second difference. So this is neither linear nor quadratic. How about here? Again, these are the same. Let's look here. What do I do to get from 10 to 3? I subtract 7. What do I do to get from 3 to 7? I add 4. From 7 to 22, I add 15. What do I do to get from negative 7 to positive 4? I add 11. What do I do to get from 4 to 15? I add 11. Second difference is the same, so this is quadratic. Okay. We can also look at that in this direction. Okay? So you try both of these. Go ahead and pause it here. All right, so the first thing we have to do to get from 0 to 2, we add 2. To get from 2 to 4, we add 2. To get from 4 to 6, we add 2. To get from 6 to 8, we add 2. So every time we are adding 2, my x's are going up by a constant rate. How about my y's? I'm going down by 2. I'm going down 1. I'm going 0. And I'm going up 1. Well, from negative 2 to negative 1, I add 1. From negative 1 to 0, I add 1. From 0 to 1, I add 1. First difference, not the same, not linear. Second difference is the same. This is a quadratic. Okay. How about here? I add 1, I add 1, I add 1, I add 1. Each time I'm adding 1, my x's are changing at a constant rate. How about my y's? I add 1, I add 2, I add 4, I add 8. So not linear, not the first difference. Here I add 1, here I add 2, here I add 4. Second difference is not the same. So this is neither. It's neither linear nor quadratic. Okay? All right, let's move on to what we have about inequalities. You should have the notes for today. Steps to solving quadratic inequalities. First step says to get it into standard form. We've been doing that all along. Anytime you see an inequality, you want to get it in standard form. We're either going to solve by factoring or by using the quadratic formula. Once we've done that, if we've got the quadratic formula, there we've got our answer. If we factor, we set each factor equal to 0 and solve. Then we're going to use these answers that we got here in number 3 as our endpoints for our intervals, and we're going to test a point in each interval, and then we're going to graph the inequality because we have to determine where we want to use this. So let's take a look at an example. You have one on the bottom of your page. All right, let's take a look at this one. It is already it is already set equal to 0. There's nothing on it this side that we need to bring over, and we're going to think about setting it equal to 0, and then we're going to use those as our endpoints. So we're going to factor it. So remember, a equals 1, b equals negative 3, c equals negative 4. So we need to ask ourselves, what multiplies to give me negative 4 and adds to give me negative 3? Well, negative 4 and a positive 1 will do that. So this is going to factor into x minus 4, x plus 1, and we're going to think about it as being equal to 0. We're going to use that for right now, and then we'll go back and we'll test our inequality. Okay. Now, I did this the British method, so I should divide by a, but a is 1, so it doesn't impact anything. So I'm not going to rewrite that. I'm just going to erase those. Okay. So now I set each part equal to 0, just like we've done before. We've set x minus 4 equals 0. I don't really need those parentheses, do I? Now I say x plus 1 equals 0. Adding 4 to both sides, I get x equals 4. Subtracting 1 from both sides, I get x equals negative 1. So now I'm going to draw my number line. Okay. Here's my negative 1. Here's 0. Here's 4. Now, because this was less than or equal to, these are going to be closed dots here. It's going to be a closed dot here, and it's going to be a closed dot here. But we need to figure out, are we talking about the stuff in between, or are we talking about the stuff on the ends? So we test a point. What is an easy point to pick between negative 1 and 4 to plug into here? Right, we can pick 0. So we put a 0 into here. I get 0 squared minus 3 times 0 minus 4 is less than or equal to 0. And I want to know, is that a true statement? So is negative 4 less than or equal to 0? Yes, it is. So that tells me that everything in here, in between here, should work. Now, it's not a bad idea to pick something outside this interval. So let's pick, let's say, 5. Okay? So 5 squared minus 3 times 5 minus 4. Is that less than or equal to 0? Well, that's 25 minus 15 minus 4. 25 minus 15 is 10, minus 4 is 6. 6 is not less than or equal to 0, so no, not this side of this 4 does not work. The same thing would be true if we picked a number less than negative 1. Let's try a negative 2. So negative 2 squared minus 3 times negative 2 minus 4. Is that less than or equal to 0? Well, this is 4 plus 6 minus 4. 4 plus 6 is 10 minus 4. 10 minus 4 is 6. Is 6 less than or equal to 0? No. So nothing over here works. So we were correct here. Always want to graph your answer on a number line. Always have to check your input or check your endpoints there. Let's try another one. You've got another example. This one. Now, what's different about this one than the previous one we did? Right. It's not set equal to 0. So we have to set it equal to 0 first. So I have to subtract the 3. I have to subtract the 3. And I get x squared plus 7x plus 10 is greater than 0. Now I think of that as the inequality, or the equality, and I'm going to factor it. A is 1, B is 7, C is 10. What multiplies to give me 10 and adds to give me 7? A positive 5 and a positive 2 would give me a positive 7. So that's going to factor that into x plus 5 times x plus 2. And we're thinking about that equaling 0 because we're going to find our endpoints. So I say x plus 5 is equal to 0 or x plus 2 is equal to 0. If x plus 5 is equal to 0, then x equals negative 5. If x plus 2 is equal to 0, subtract 2 and we get x equals negative 2. Those are my endpoints. So here's my number line. Here's negative 5, negative 4, negative 3, negative 2, negative 1, 0. Not very well spaced, but that's okay. I look back at this original inequality. It was a greater than. So if it's greater than, these are going to be open dots. So open dot here and open dot here. Now, 0 isn't in between these two. 0 is over here. So let's just test to see what happens when we put a 0 in. Put a 0 back into the original, or you can put it back into this one. It doesn't matter. 0 squared plus 7 times 0 plus 10 is greater than 0. So that says 0 plus 0 is 0 plus 10. 10 is greater than 0. Is 10 greater than 0? Yes, that's true. So it's true out in here. So these are the values that we're going to need. Well, let's pick a number in between. We can pick negative 4 or negative 3. Make it the easiest number you can. So let's plug a negative 3 in. Negative 3 squared plus 7 times negative 3 plus 10 is greater than, not greater than or equal to, just greater than. Okay, so that's 9 minus 21 plus 10. 9 minus 21 is a negative 12. Negative 12 plus 10 is negative 2. Is negative 2 greater than 0? No. So it doesn't work in there. Now we have to pick something less than negative 5. So the easiest thing to pick there would be a negative 6. So let's try negative 6. And I'm going to give myself a little bit more space here. Oh, I've got a number line down there and I didn't remember it. That's all right. I'll go ahead and still graph it up here. So negative 6, we're going to plug that in. Let's grab a different color here so it stands out a little bit more. Let's try negative 6. I'm going to go down below here. Okay. The original equation was as x squared, so negative 6 squared plus 7 times negative 6 plus 10 is less than 0. And we want to know, is that true or not? Negative 6 squared is 36. 7 times a negative 6 is a minus 42 plus 10. 36 minus 42 is a negative 10. A negative 6. Negative 6 plus 10 is a positive 4. Is 4 less than 0? No. All right, what did I do wrong here? When I brought my problem down, this should have been greater than 0. Is 4 greater than 0? Yes. So on our number line, negative 6 works. So anything over here works. So what would my solution be? I would have an open dot on negative 2. I would have an open dot on negative 5. And I would have arrows going in the opposite direction. This tells me it can't be between negative 5 and negative 2, so that's why it's not true. All right, you try this one on your own. This one's a little trickier, just because A is not 1, but you can do it. Why don't you pause it here so you can try this? All right, let's talk about this one now. Not set equal to 0, so the first thing you have to do is subtract 5 from both sides. So you get 2x squared plus 7x minus 15. Make sure you're subtracting is greater than 0. So A is 2, B is 7, C is negative 15. I need something that multiplies to give me negative 30 and adds to give me 7. Well, how about negative 3 and positive 10? Okay. Let's just do this one split the middle because we haven't done that in a while. So I have 2x squared minus 3x plus 10 minus 15. And again, we're going to think about it as being equal to 0. GCF for this is x. So I have 2x minus 3. Oops, I dropped my x there. GCF for that is a plus 5. And that leaves me with 2x minus 3 as well. So when I factor this, I get 2x minus 3 times x plus 5 equals 0. Set each piece equal to 0. So 2x minus 3 equals 0. Got the equal sign there, sorry about that. Or x plus 5 equals 0. Subtracting 5 from both sides, I get x equals a negative 5. Add 3 to both sides. Divide both sides by 2. And x equals 3/2 or 1.5. Okay. So now let's come down here to our number line. It's greater than. So negative 5, since it's greater than, it would be an open dot. 1.5 would be right about here, open dot. Easiest thing to test is this 0, so let's plug a 0 in and see what happens if we... Okay, so going back to that original, 2x squared plus 7x minus 10 is greater than 5, or you can put it in here, it doesn't matter. So we're going to test 0. 2x squared plus 7x minus 15 is greater than 0, but we're supposed to be testing the 0. So let's go ahead and plug the 0 in. So I have 2 times 0 squared plus 7 times 0 minus 15, and we want to know, is that greater than 0? 2 times 0 is 0. 0 squared is 0 times 2 is still 0. 7 times 0 is 0. So is negative 15 greater than 0? No, it's not. So it is probably not in there. we still need to pick numbers over here and a number down here just to double check. So easy number to pick for here. Let's pick 2 since it's bigger than it would be in this part of the number line. So let's try a 2. So if we plug 2 in, we get 2 times 2 squared plus 7 times 2 minus 15, and we want to know, is that greater than 0? Again, make sure we square this first. So 2 squared is 4, times 2 is 8. 8 plus 14 minus 15, is that greater than 0? Well, 8 plus 14 is 22. 22 minus 15. 22 minus 15 is 7. Is 7 greater than 0? Yes. So I can have things on this part of the line. Now we need to pick something from this part of the line. Looks like negative 6 is an easy one to pick there. I'm going to move down below here so I can see it a little better. So let's try that negative 6. It was 2 times negative 6 squared. Make sure I'm getting the problem written down right this time. Plus 7x minus 15. So plus 7 times negative 6 minus 15. And we want to know, is that greater than 0? Well, negative 6 squared is 36. 36 times 2 is 72. 72 plus a 7 times a negative 6 is a minus 42. Minus 15. And we want to know, is that greater than 0? Well, 72 minus 42 is 30. 30 minus 15 is 15. 15 is greater than 0. So it looks like this part of the number line works as well. All right, you have one last problem on the back of your notes. Let's take. All right, let's look at this last one, which is an application problem. We have a business offers tours to the Amazon, and the profit P that the company earns for X number of tourists can be modeled by P of X equals negative 25x squared plus 1,000x minus 3,000. It says how many people are needed for a profit of at least 5,000. So we have the negative 25x squared plus 1,000x minus 3,000 must be at least, so greater than or equal to, 5,000. Okay, it's one of these inequalities, so we're going to do the same thing we did. We're going to set it equal to 0. Now, I like my x squared term to be positive, so I'm going to take everything over to this side. So I'm going to say 0 is greater than or equal to, I'm going to add 25x squared to both sides. I'm going to subtract 1,000x from both sides. And when I add 3,000 to both sides, I'm going to have 8,000. Okay. Now, I can see that 25 should go into each of those. So I'm going to take 0, greater than or equal to 25, and factor that out, and I get x squared minus 40x plus 320. Now, I could ask myself, does that factor? Does anything multiply to give me 320 and add to give me negative 40? It does not, so I need to use the quadratic formula. We don't have to worry about the 25. We're just going to say our A is 1, B is negative 40, and C is 320. And so we're going to plug that into our quadratic formula. Remember, it's x equals negative b, which is a positive 40, plus or minus the square root of b squared, so negative 40 squared minus 4 times a times c. All over 2a, so 2 times 1. So we're going to go ahead and work this out. So I have x equals 40 plus or minus the square root, and negative 40 squared is 1,600 minus 4 times 1 times 320 is 1280. All over 2. When we work this out, we then get the two pieces. We get 40 plus or minus the square root. 1600 minus 1280 is 320 over 2. Now we could factor this out and break it down, but it's really going to help us if we have it in decimal form. So we're going to plug it into our calculator in two pieces. We're going to say 40 plus the square root of 320 over 2, and 40 minus the square root of 320 over 2. Let's give myself a little bit more room here. Okay, so when we plug this one into our calculator, we get 40 plus 320 over 2. We end up with 28.944. And when we plug this one into our calculator, we get 11.05. Now, we're going to look at putting this on a number line. So we can determine where do we want to put this. So I've got 11, I've got 12, and then over here I'm going to have 28 and 29. Okay. Now that first number was 11.05, so it's going to be right here, and it's going to be a closed dot, very close to the 11. The last number was a 28.944, so it's going to be a closed dot, very close to the 29. Not over the 29. Let's make sure I get that where it needs to be. All right, so now we need to test some intervals. When we test this interval, we look at some number in here, and we're going to look at some number over here, and some number over here. Now, I just chose 12 to plug in for over here. So if I plug a 12 in, remember my original equation, this is the one I'm looking at. The 0 is greater than or equal to 25 times parentheses x squared minus 40x plus 320. Okay. So if I plug in a 12, I want to know, is 0 greater than or equal to 25 times 12 squared minus 40 times 12 plus 320. If I work this out, I get 0 is 0 greater than or equal to 25 times a negative 16. Well, this is going to be a negative number. So is 0 greater than or equal to a negative number? Yes, it is. So we're looking in here, looks like it should fulfill what we want. It's not a bad idea to test a number over here and to test a number over here. Number over here is really easy to test because 0 is over here. So let's put a 0 in. Is 0 greater than or equal to 25 times 0 squared minus 40 times 0 plus 320. So is 0 greater than or equal to 25? This all is 0, so this is 25 times 320. No, 0 is not greater than or equal to that, so no, this is not an acceptable area. Do the same thing over here. I chose 30 just because it's easier to square. So we have 0 greater than or equal to 25 times 30 squared minus 40 times 30 plus 320. Okay. Is 0 greater than or equal to 25 times 20? Well, no, that can't be. so it's not out here. So it's in this range in here. We'll give them a profit of at least $5,000. But we have to think about this. This is talking about people. I have to have at least 11.05 people, which means I have to have at least 12 people because I can't have 0.05 of a person. I can't have 0.85 of a person. I can't have more than 28.994. So the biggest number I can have is 28 people. So what is my range? My X is between 12 and 28 people. That would maximize my profit. Okay? All right, let's take a look at what your assignment is for tomorrow. Work on those, please.